There are moments in humanity's exploration of space when everything unfolds exactly as science predicts. Equations align with observations, instruments confirm theories, and the universe behaves according to the physical laws we have spent centuries uncovering. Each successful mission strengthens our confidence that, no matter how vast the cosmos may be, it can ultimately be understood. But every so often, something happens that refuses to fit inside those equations. Not because our technology fails. Not because our instruments make mistakes. But because the universe reveals a chapter we never expected to read. Far beyond the orbit of every planet, farther than sunlight can warm and farther than the solar wind can easily reach, a lone spacecraft continues its silent journey. Voyager 1 was never designed for this moment. Built with technology that predates the modern internet, it was expected to survive only long enough to explore Jupiter and Saturn before fading into history. Instead, nearly 5 decades later, it continues drifting through interstellar space, carrying humanity's voice farther than any object we have ever created. Against every prediction, it still communicates. And recently, something about those communications forced scientists to ask questions they never imagined they would face. The signal arriving from Voyager was unlike anything engineers had encountered before. It wasn't the familiar background noise produced by distant plasma. It wasn't interference from the sun or corruption caused by aging electronics. Instead, hidden within the data were patterns that appeared unusually organized, repeating in ways that demanded careful attention. For the first time in decades, one of the oldest spacecraft ever built seemed to be witnessing something entirely unexpected. Imagine dropping a bottle into the middle of an endless ocean, believing it will drift forever through empty water. Years later, another bottle returns, carrying markings you don't recognize. You cannot explain who found it, where it traveled, or why it came back. That unsettling image captures why Voyager's latest observations have fascinated both scientists and space enthusiasts around the world. Tonight, we follow the incredible journey of this legendary spacecraft, from its historic launch, through the giant planets, across the edge of our solar system, and into the vast darkness between the stars, to understand why a machine powered by aging plutonium and guided by 1970s engineering continues rewriting our understanding of deep space. Before we can understand the mystery, we first have to understand the traveler. When Voyager 1 lifted off in September 1977, its mission appeared remarkably straightforward. Visit Jupiter. Continue to Saturn. Photograph these distant worlds in extraordinary detail. Measure their magnetic fields, radiation environments, and atmospheres. Then, once its primary objectives were complete, continue drifting silently through space until its power eventually disappeared. No one expected the spacecraft to become one of history's greatest engineering achievements. Yet year after year, decade after decade, Voyager continued operating long after many believed its systems would fail. Today, it remains the most distant human-made object ever launched, traveling billions of miles from Earth through an environment no spacecraft had ever explored before. Its hardware is astonishingly modest by today's standards. Its computer possesses less processing capability than the simplest modern electronic devices. Its memory is tiny compared with even a single photograph stored on a smartphone. Every command transmitted from Earth requires many hours to arrive, and every response takes just as long to return. Despite those limitations, Voyager has endured conditions that would challenge even modern spacecraft. Its electricity comes from radioisotope thermoelectric generators powered by slowly decaying plutonium. Each year those generators produce a little less energy, forcing NASA engineers to carefully shut down non-essential instruments to keep the mission alive. Even so, Voyager continues sending valuable scientific information from a region no human has ever visited. It has become much more than an explorer. It has become humanity's only permanent observer in interstellar space. Every transmission arriving from the spacecraft expands our knowledge of the invisible boundary separating our solar system from the rest of the galaxy. That alone would make Voyager extraordinary. But recent observations have renewed interest in data collected throughout its entire journey, prompting researchers to re-examine measurements that once seemed insignificant. The story truly began long before Voyager entered interstellar space. Its first great encounter came with Jupiter. Nothing prepared scientists for what they found. As Voyager approached the giant planet, cameras revealed a world unlike anything previously imagined. Massive storms stretched across thousands of kilometers, dwarfing Earth itself. Lightning flashed through enormous cloud systems with incredible intensity. Radiation belts surrounding Jupiter proved so powerful they threatened sensitive electronics, while the volcanic moon Io astonished researchers by blasting enormous plumes high above its surface.